Hello, my dear children of class 11 science. I again welcome you all through this mode of teaching, that is through YouTube mode. And in this class, this period of class, okay, we do again continue with the chapter that is surface tension. So in the last class and up to the last YouTube video, we had done up to the relation between surface tension and work done in increasing surface area. Okay. Now there are some important numericals, okay, that we need to solve. And that's numerical also help you a lot to understand more about the chapter that is called surface tension. Okay. Now let's start with problem number 1. Let's start with problem number 1. And problem number 1 says that the surface tension of a soap solution. The formation of soap solution is also due to what tension? Surface tension. But what is the surface tension of soap solution? Is given 0.030 Newton per meter. So let me just write down surface tension of soap solution, basically marked by letter T, that is 0.030 Newton per meter. Okay, this is the surface tension of soap solution. Now question says that how much work is required to form a bubble? How much work is required to form a bubble of 1 centimeter radius from the solution? From this what? Solution. So what is 1 centimeter out here? Is the radius of the bubble that has to be formed. But in order to form the radius or bubbles of radius 1 centimeter, the work has to be done. Okay, work has to be done. Now this radius is given. Now radius, let me mark the radius by small letter r, and this radius is 1 centimeter. Yes, I can change centimeter into meter. So what you need to do? You have to multiply by 10 to minus 2. Because 1 centimeter means 10 to minus 2 meter. That's why I can write 1 into 10 to minus 2 meter. So this is the radius of the bubble. Now for the formation of this bubble of radius 1 centimeter, then definitely there is an area of the bubble which is formed by the soap solution. Okay. Now this area is a what area? Surface area. So we calculate now the surface area. Surface area of soap bubble. Now this soap bubble is usually what in shape? Spherical in shape. And the surface area of sphere is basically what? 4 pi r square. 4 pi r square. So let me substitute the value. 4 pi r means how much? 10 to minus 2 with whole square, which is 4 pi into 10 power minus 2 to the 4, and the unit will be meter square. So this is the surface area of soap bubble. But children, one thing I want to add in this question is that soap bubbles has two surfaces, two free surfaces. Okay, one is the external surface, and another is what? Internal surface. So just take a note that since soap bubble, okay, soap bubble always has how many surfaces? Two surfaces, two free surfaces. Okay, and these surfaces are nothing but one is external surface, external, and what surface? Internal surface, internal surface. Okay, so if there are two free surfaces of these soap bubbles, then there are two surface area of the soap bubbles. So that means what is the total surface area now? For the total surface, I calculate the total surface area, okay, of soap bubble. What bubble? Soap bubble is given by A. So I write down A is the total surface area, and this area is nothing but 2 times the surface area of each bubble, first surface. So this surface area of soap bubble is the first surface area of the soap bubble. But there are two surface area of the soap bubbles. That's why I just multiply by 2. So 2 into this quantity I'll multiply. That is 4 pi into 10 to the power minus 4, and the unit is meter square. So now see what is the total area? It is 8 pi into 10 to the power minus 4. Okay, let me write down 8 pi into minus 4 meter square. But children, we can put the value of pi also. So let me write down 8 into pi means how much? 3.14. Yes, we have learned pi means 3.14 into 10 power minus 4 and meter square. So 8 into 3.14, if you multiply, it will be 25.12. Yes, children, you can use calculator and multiply. It will be 25.12 into 10 power minus 4 meter square. So this is the area of total surface area of the soap bubbles. Now in order to form this surface area of soap bubbles, the work has to be done. That means we now calculate the work done in making the bubbles. And this work done in making the bubbles of radius, how much? 1 centimeter, okay, is actually stored in the form of the energy, okay, known as what? Energy. And this energy is also called surface energy. Okay, now to calculate the energy, okay, that is stored in the soap bubbles, okay, and this energy which is stored is actually formed by doing work for making the bubbles of radius how much? 1 centimeter. So basically I calculate work done now. So I write down work done is equals to surface tension, and the formula I am using is surface tension into area, because surface tension means work done by area, then work done equals to surface tension into area. So children, we can calculate work done in terms of surface tension and area, because surface tension of soap solution is given 0.030 Newton per meter. Area in which the soap bubble is formed, we also calculated. So from here we can calculate the work done. So what is the surface tension of soap bubbles? 0.030 Newton per meter. The area is how much? That we calculate the total area, that is 25.12 into 10 to the minus 4. Okay, so now we can do the calculation. We can simply multiply. Now these two quantity can be multiplied with the help of calculator. If you do multiply these two quantity, it will be 0.7536. Children, you can do use calculator and calculate multiply these two quantity. You get 0.7536 as the value. So into there is 10 to the minus what? 4. Now this answer I'll write in single digit. So what I do, I shift this decimal to one decimal right, and there is a negative power. If there is a negative power and if I shift this to one decimal right, then your power increases by 1. So if there is a negative power, then if you shift one decimal to right, your power increases by 1. Okay, means I write down this is 7.536 into 10 power minus 5, and the unit is joule. But one thing I want to tell you and remind you that in your notes you might find the power not as minus 5, it is minus 3, but actually the power should be minus 5. So please do the correction. So by mistake I may have written minus 3, but please do correction, children, when you copy these problems in your exercise copy. So the answer must be 7.536 into minus 5, and the unit is what? Joule, because we measure work done by unit what? Joule. So what is the how much amount of work that is required to do to form a bubbles of 1 centimeter radius of soap solution? 7.536 into minus 5 joule. Okay, so this is the explanation of problem number what? 1. Now we go to the next problem, that is problem number 2. And children, your problem number 2 I'll solve in the next YouTube video. Thank you so much.